Hi everyone, let's work on 3.3 homework, which is about properties of functions. I'm going to start with question number 3. It's asking us to list the intervals on which the function f is increasing. So I'm going to put my pen on the left side of the graph and I move from left to the right. And I see that the first part, the graph, is going down. My pen is going down as well. Starting this point, the graph is going up until this point. After that, again going down, then it's going to go up from this point to here and down, and this part is going up. So we have three parts of the graph that it's increasing. So in order to write the interval that the function is increasing, you need to write x of the start and x of end, and you put parentheses around it. So the first point here that the function is going up, the x of that point is negative 10. So I write negative 10. And then the last point is at negative 4. So you write only the x value of that. You don't write the y value. And same here. This is starting from negative 2 and ends at 0. Next one starts from 3 and ends at this point, which is 5. So this is how you write the increasing, decreasing interval. Question number 4, we're using this graph to find the local minimum of the function. The local minimum of the function. So as you see, this function is going to continue forever from the left and the right side. So these points cannot be counted as any maximum or minimum points. But we have a local minimum, which is this point, which is the lowest point of all the points around that. And the same here, this one is also lowest of all the points around it. So the first part of the question, the x of these points are the only thing that you need to write. So here, this is at x equal to negative 1, and this one is at x equal to 3. So you just write the x value. And next one, it says, what are these local minima if they exist? So for this part, you need to write the y value of these points. So the y of this point is negative 1. The y of this one is also negative 1. So it shows negative 1 and negative 1. Question number 6, we need to use this graph to answer some questions here. The first one is saying, what are the intercepts of the function? So intercepts are where the graph is crossing x-axis, which is called x-intercept, or the y-axis, that's called y-intercept. So I see that one of them is here. This is where the graph is crossing the x-axis. So I can write negative pi and 0, because I know the y value at this point is 0. Next one is this. This is an x-intercept and y-intercept because it's crossing both of them, and it's at 0 and 0. And the last one is here. This is at pi and 0. So these are x and y-intercepts. Now the domain and range. For the domain of the function, you need to move from the left to the right and look at the x values, see what if there's any limits or restrictions or not. And I see that the first point of my graph is negative pi. So you're looking at the x values only. Starts from negative pi, and there is no restrictions here. Pi is the last point. So here I'm going to write from negative pi to pi. However, because these points are part of my graph, they're included, so I'm going to put bracket here. For the range of the function, you're going to move from bottom to top. And this time you're going to look at the y values. So here, as I'm moving from bottom to top, this is the lowest point of the function. So what is the y value of that? It's negative 7. And I move forward to the top part of the graph, and here's the last one, the highest one, and that's 7. So this will be the graph, the range of my function, and I don't forget to put brackets because those points are also included into the function. Now it's asking us where is the function increasing. So as you see, this function is increasing from this point to this point. This is where the function is increasing. Here is decreasing, but this one is increasing. So all you need to do, write x of start and x of end. So it's going to be negative pi over 2 over pi over 2. And you're going to use parentheses. Always for increase, decrease, you're using parentheses. And then it's asking us, where is the decreasing area? That's the next part of the question. For decreasing area, you're going to write, let me erase this for you. This time, you need to write x and x of the start, x of end of this section, and this one. So x of the start is negative pi. X of end is negative pi over 2. This is the first part. Second one, x of the start is pi over 2. X of end is pi. So you're going to write them in this form. And also, there's no part on the graph that is decreasing. Constant. So there's nothing to write about this. And last part is asking if the function is even or odd. The function is odd because I see that for every point on my graph, there's a mirror on the other side of the origin. This function is symmetric to the origin. You see, this point has a mirror on this side. This point has a mirror on this side. So if the function is symmetric to the origin, it's odd. And also you can see if a function is symmetry to the origin and it's odd, if you have pi over 2 and 7, you're going to have negative pi over 2 and negative 7 on that function as well. That means if you have x and y on your graph, negative x and negative y are also on the graph. So this is the second way to identify an odd function. Question 9 is asking us to find if the function is even or odd or neither of them, but this time we want to find it algebraically. So in order to find it algebraically, the first thing that you need to do is to try f of negative x and see if it's equal to negative f of x or not, or if it's equal to f of x or not. So in this case, if this happens, the function is odd. If the second one happens, the function is even. So I'm going to start with f of negative x and see what is f of negative x. So that means in your function, wherever you see x, replace that with negative x. So here I will have negative 4. Let me write that again. I have negative 4 times x plus 2 inside the absolute value x. So I'm supposed to have x here, but instead of x, I'm going to write negative x, and the same here. Now, start simplifying. Negative 4 times negative x makes it 4x. And next one, negative 2 times negative x is negative 2x. However, the absolute value of that will make it positive 2x. So this is what I will have. And I'm going to put the absolute value bar here as well. So we know that absolute value of negative 2x is basically just absolute value of 2x because absolute value makes everything positive. So this is my final function now. But is this equal to f of x? It's not. So this is not an even function. Now I need to check if it's odd or not. So this time I'm going to find negative f of x and see what is happening this time. So negative f of x, that means whatever is your function, just put a negative behind that and then simplify. Loss absolute value of 2x here. Now the negative is going to be distributed. This is positive 4x, and here I will have negative absolute value of 2x. And this is not equal to negative, this is not equal to f of negative x. So none of them is happening here. That means the function is neither. Question number 11 is asking us to use a calculator and graph this given function over this interval and then answer some of the questions here. So I'm going to use my calculator here. So in this case, I'm going to press y equal and enter the function. So I've already done that here. Now I need to make sure I have the right window. I'm going to use these values that are given. X between -2 and 2, y between -4 and 10. So here I go to window, x min is -2, x max is 2, and y min -4, y max is 10. So I define my window. Now I can graph the function, and this is how it looks like. So I see that the graph of the function is t. This is the right graph. Now we're going to answer some questions over the function. So we need to find the local maximum. So here I'm going to find the local maximum. I'm going to go second trace, and number 4 is maximum. So press enter here. Now it's asking what is your left bound. So I'm going to move the cursor to the left side of where I think it's the maximum point. And I know it's right here around this point. So left bound, enter. And then it's asking what is your right bound. Go to the right side of this point, enter. And now it says, what is your guess? Move your cursor almost to the top of that point. It doesn't have to be very accurate. Then you press enter and it's going to give you the value. The x is 1.00001 and y is 4. I mean, it was -1. X is -1. So now I can enter the value here, which is 4 and -1. Okay, next one is asking us find the local minimum point, which is this point. So again, second trace, and this time you go to number 3 and left bound, left side of this point. I'm already on the left side. And then right bound, move the cursor to the right side of the point, enter. And what is your guess? Move close to that point and enter. Now it's going to give me the point. The value of the minimum is given. It's 0.99999 and y is 0. So here, because we're rounding to the two decimal places, I can just write the x is 0. I'm sorry, the value of the local minimum is 0 at x equal to 1. Then we need to find the increasing and decreasing parts of the function. So for first part of the function, I'm going to write them here for decreasing. And I'm going to write the increasing also here. Okay, so the first part of the function, I see that the function is going up until this point. So all I need to do, write x of a start, x of n. X of a start is -2. X of n is -1. Put parentheses around it, comma. And now the next increasing part is from here to here. So that's from 1 to 2. So I'm going to write 1 to 2. Just write x of those values. And then decreasing part is from this point to here, which is from -1 to 1. X of a start, x of n. For question number 13, we need to find the average rate of change of f of x, which is given here, over each of the following intervals. So basically the formula that we're going to use here is f of b minus f of a over b minus a. So b and a are these two numbers basically here. And f of b and f of a are f of the function if the x is equal to any of these values. So here, if I want to find the average rate of change for 4 to 6, I just need to do f of 6. So I'm going to call this a, this one b. F of 6 minus f of 4 over 6 minus 4. And the same for the other ones, f of 4 minus f of 2 over 4 minus 2. F of 2 minus f of -1 over 2 minus -1. Now, in order to find each of these, all you need to do is to plug in this value into your function. So here, if I want to find f of x, I'm just going to write -3. Instead of x, I replace 6. And then the rest of the function. So this is f of 6 minus, and then here f of 4. Just replace x with 4. And in the denominator, we have 6 minus 4. So once you evaluate each of them, divide them, and you're going to find the answer. So this is just the general form to solve these questions. Okay, so for next question, the function is given and it's asking us to find the rate of change from -1 to 3. So this is the same thing as we did before. This is my A, this one is B, and I'm using the same formula, f of B minus f of A over B minus A. So just replace those values, f of 3 minus f of -1 over 3 minus -1. And then you're going to evaluate each of them and find the answer. The answer that you find here is average rate of change from -1 to 3, but at the same time, it's the slope of the secant line that is passing through these 2 points. So let me just show you this. Let's say this is my graph of 5x squared minus 4, something like this probably. So from -1 to 3, let's say this is -1, and somewhere around here, let's say this is 3. So average rate of change from -1 to 3, basically I'm asking, the question is asking me, what is the slope of the line that is passing through these 2 points? What are these 2 points? These are f of 3 and f of -1. These are the y value of this one, and the x of those values are 3 and f of 3, and -1 and f of -1, which of course here instead of f we're using g, and it doesn't really matter. So anyway, once you find the average rate of change, that's basically the slope of this line. Now it's asking you to write the equation of this line, which is called secant line, that is passing through these 2 points. We know that in order to write the equation of a line, we're going to use this formula, y minus y1 equal to m times x minus x1. What is m? This is the slope of this line, which we just found it from average rate. And then x1 and y1 could be any of these two. You could choose any of them. y1, x1, I chose this one. What is g of 3? In order to find g of 3, you need to plug in 3 into the function, as I did here, and found it's 41, which we already also did that here. Anyway, so I'm just going to write y minus this g of 3, which is 41, equal to 10. That's the slope of the secant line, times x minus x1, which is 3. And then later you're going to distribute 10 and simplify, and this is the result equation. Question 15 is given this function to us and is asking us to find if it's even, odd, or neither of them. So the first thing that I can do here is find f of negative x. And we know if f of negative x is equal to f of x, this is an even function. If f of negative x is equal to negative f of x, then this is going to be an odd function for us. So I'm going to try these and see which one is right. F of negative x will be negative, instead of x to the power of 4, and here 8, x to the power of 2 plus 425, I'm going to replace negative x and see what I will have after that. Negative x to the power of 4 will be just x to the power of 4. And I already had a negative behind that. I'll keep that. And 8, again, negative x to the power of 2 is x plus 425. And I see that this is equal to f of x. So this function is an even function. And I don't even need to check this. There's another way to check if this is an even or odd function, and that is graphing my function. So I'm going to graph this function and show you how it works in that way. So here's my calculator. I entered this function into my calculator. Notice that here I have a big number, 425. This is the y-intercept of the function. That means the y value of your window should be really big. So here in the window, I define negative 10 to 20, and the y min and y max are negative 4 to 500. Now I can graph the function, and I see that this is symmetry to the y-axis. If a function is symmetry to the y-axis, then this is an even function. So this was the second way to find if the function is even or not. Now, the next part of the question is asking us to find it's just telling that there is a local maximum value of this 441 at x equal to 2. We need to find the second local maximum value. So here I have the graph of the function. So a local maximum is at x equal to 2, and the value of that is at 441. So this maximum that is given to us is here. This is at x equal to 2 and y is 441. Since I know this is an even function and it's symmetry to the y-axis, so the other one will be here. And I know that if you have an even function and you have x and y on the function, you will have negative x and y as well. So that's how I know this is symmetry to this point. So the other one will have a negative 2 value. So the other local maximum will be, again, 441. They have the same y value, but the x is opposite. Now, then it says the area of the region enclosed by the graph f and the x-axis between x equal to negative 5 and x equal to 0 is how much? Because I'm already given that the area between 0 and 5 is 1833.3, and that's this part. You see, this is the area under the graph, which is between 0 to 5. Now, what is the area between 0 to negative 5? That's the opposite side of that. And since they are symmetry, that is also going to be exactly equal to this. And I don't even have to calculate anything. Just by looking at the graph, I know there are symmetry. So left and right side of the graph are exactly like each other. Okay, so question 16 is asking us to find the average rate of change for all these points. The function is x squared. So in order to find average rate of change between 7 to 8, as we know, we're again using the same formula that we already know, f of b minus f of a over b minus a. So you replace f of 8 and f of 7 over 8 minus 7. We found it, and it's equal to 15. And we're going to do the same thing for all the other values. This is the second one, f of 7.5 to minus f of 7, and so on. So as you see, the numbers are getting closer and closer to 14. So it was 15, 14.5, 14.1, and so on. The number is getting closer to 14. So I can write here to what number the slopes of the secant lines are getting closer. So I can write 14. However, now this part, let's talk a little bit about this part. So here's the graph of my function. And also, this is the secant line that is passing through 2 points. So let's say this is x equal to 7 and this is x equal to 8. Now, as you see here, each time we are making the distance between these 2 points is smaller and smaller. So 7 to 8, 7 to 7.5 to 7.1, and so on. So the line is getting, the second point is getting closer to the first one. So if I move this point here, which is a little bit closer to the first point, this is what is going to happen. See, so the secant line is going to look like this. Now, next time I make the point closer again, and this time the secant line is going to look like this. Again, I'm going to do that 2 more times, and we'll see what is happening. This is the next time, and here's the last one. You see? So that means the slope of the secant lines are getting smaller and smaller. You see the slopes are getting smaller, and the secant lines are beginning to look more and more like the tangent line to the graph of f at point x equal to 7. So it's getting closer to look like more a tangent line rather than secant line. So we know that if I have a graph and a line passes this way from the graph at 2 different points, we call that a secant line. But if I have a graph and this time the line is passing exactly at the one point, it touches and passes, this one is called a tangent line. So the point of this problem is this: as we make this distance smaller and smaller, what happens to the secant line? It's going to be a tangent line. Okay, next question, question 17 is asking us to look at this function and then express the slope of the secant line in terms of x and h. This means basically finding this expression. That means f of x plus h minus f of x. That means if you have a point on your, let's say this is my graph, this is x, you go just h, the distance of h after that, let's say this point, this is x plus h. So the distance between these 2 points, the horizontal distance is h. And we are interested to know what is f of x plus h minus f of x over x plus h minus x. So all I'm going to do here is replace x with x plus h into my equation over here. So this is going to be 10 times x plus h squared plus 3 times x plus h. So just replace x with this. And minus f of x, which is just the whole function. Now, after this point, we're just going to do some algebra. Basically, we're just going to distribute and simplify. X plus h squared, I just wrote that here. That means x plus h times itself. And you distribute and simplify, this is what you're going to get. So I wrote that here for you. Next, you're going to distribute the 10. So you distribute the 10, you're going to get all these terms. On the other hand, 3, distribute the 3, and you're going to get these. And the negative needs to be distributed as well. So this is your result, and now you're going to simplify. What do you see? What are the terms that you can cancel here? 10x squared and negative 10x squared, 3x and 3x. And you're left with this expression. Also, I see that h is in common between all these, and I have an h in the denominator. So I factored h out, and I have 20x, 10h, and 3. The h is going to cancel from top and the bottom, and this is what you have here. Now, next is asking if h is equal to 0 and x equal to 1, what is the slope of the secant line? That is the slope of the secant line, basically, which is passing through these 2 points. So what is that? All I need to do is this formula that I have, I'm going to use it and replace x with 1 and h with 0.5 and calculate. The same is for next question and the next one. So let's see what is happening here. Look at the values at 28 first. At first, the h was 0.5. Next time, h is smaller, 0.1. So the slope is also smaller. And next one is 0.01. The slope is getting smaller again. So as I see that as h approaches to 0, when you say approaches to zero, that means it's getting smaller and smaller and smaller. Then the slope is going to be smaller as well. And here, this is the equation for the secant line at x equal to 1 with h equal to 0.01, which was this one, basically the one that we already found. We want to find the equation of the secant line. So again, this is my x, this is x, and then here I have x plus h. The secant line that is passing through these 2 points, we want to find the equation of that. We already had the slope at 23.1. We're going to use it, 23.1. And the equation that I'm going to use is this. I need to know what is my x1 and y1. Well, x is equal to 1, and I need to find what is y1. Just replace x equal to 1 into the formula that we have. That is the original function here. You're going to replace that here. 10x squared plus 3x. So I'm going to write that here again. 10x squared plus 3x. You replace that here, and you find the y value. So this is my x1 and y1. Now I have the slope. I have these two. I replace them here and solve to get the equation of the line. Here's question 23. It says on the interactive screen that we have here, check the show symmetry and check the show coordinates box and select this function and then compare the values of x and y as you're moving the x slider. So let me show this to you. Okay, so here I already selected this function and I clicked on these two. So I chose show symmetry and show coordinates. And now I'm just going to move this x slider and compare the values of the function. So here right now, let's say here, x is 1.64 and y is negative 4.37. The other point on the other side is negative 1.64 and positive 4.37. So you see, this is positive, this one is negative. On the other side, x is negative, y is positive with the same value. Now let me just go somewhere else here. 2.89, 9.35. On the other side, I have negative 2.89 and negative 9.37. So both these values have opposite sign on this side. And the same is for any other point that you compare here. So first of all, I want you to pay attention and notice that this function is an odd function because any point on one side of the origin has a mirror on the other side. You see, any point here has a symmetry on the other side. So now let's go back to the question. It says if point 1.8 is on the graph, what must be coordinates of the another point on the graph? Well, so we learned that if there's any point on this graph, there is opposite of both of them, x and y, on the graph as well. Why? Because this is an odd function, because it was symmetry to the origin. Okay, so this was some of the questions of 3.3. I hope it was helpful for you. Have a great day.